Hi everyone. Today we are going to learn how to model dynamic resources in the simulation. As you remember, as you know, we already have learned how to use resources in our simulation. So far we have used resources mainly for the movement of the entities between different locations. And that's what we call static resources. So for those resources, all we specify is the move time, okay, or movement time. Um, but for dynamic resources, we not only take care of the movement time, but also we specify a specific path. So if our resource has to go to a specific path to go from one location to another, we can specify the path, we can specify the speed of the resource, we can specify the length of the path, and also if there are sometimes associated with the, let's say, pickup of the entities, or sometimes associated with the drop off of the entities at locations, we can take those into account as well. And the other important advantage of dynamic resources is that when we run the simulation, we can also see them in the simulation. For static resources, we don't see them in the simulation at all. We are going to see how we can basically model dynamic resources in the simulation, in the Pro model. Okay, so the model that we are going to do together is this one. So we are going to create a new model in the folder for this week. We are going to name this model as GearShop dash resources, or you may want to put dynamic resources, since we are dealing with dynamic resources. And in this model, basically, we have 5 locations. So what happens here is that we have blank as our entities. They arrive, they come to the receiving area, the receiving location. The inter-arrival time of blanks is 20 minutes, exponentially distributed. From receiving, the blanks go to either late 1 or late 2. So these two late machines are in parallel, working in parallel. However, we don't want to just increase the entity of the late machine to 2. We want to create 2 different locations for these 2 entities, for these 2 locations. So create 2 locations, for one for late 1 and one for late 2. So anyway, the parts, the blanks come, they go to the receiving. From there, they go to one of the late machines, either late 1 or late 2. And when they are done at any one of these late machines, the entity that is coming out of the late machine is cog. And the cogs go to degreasing machine. And from degreasing, the cogs go to inspection machine. And from inspection, they go to, they basically exit the system. Okay. Um, the entity that comes is blank. They go to late 1 or late 2 as blank, but then coming out of blank, they change to cogs, and then they go to degreasing, and then to the inspector, and then from inspector they leave the system. Okay, so we are going to move these entities between these locations using a resource. And what we know about the distance between this location is that the distance from receiving to late 1 is 500 feet. The distance from late 1 to late 2 is 200. Late 2 to degreasing is 200. Degreasing to inspection is 200. And finally, inspection to receiving is 500. Okay, so these are the distances between these 5 locations that we have. So we need this information, so we can tell our resource in the simulation that what is the distance between these resources, and how the resource has to navigate between different machines, or between different locations. Okay, so all the locations except the receiving have capacity of 1. Receiving has capacity of infinity, and I have also put the processing time of these locations next to them. Late 1 or late 2, they are working in parallel, so they have the same processing time. Degreasing uniform 5.1 and inspector normal 8.4. Okay, so let's go to the simulation and model this case and see how we can implement the scenario of dynamic resources. Okay, so going to locations, so as I said, we have receiving, we have late 1, late 2, inspect and decrease. As I said, all the locations except receiving have capacity of 1. And for the receiving also, I don't have the first in, first out. So this is just a placeholder. When the entities come to this area, then they gradually get to the system and get processed. Just make sure for late 1 and late 2, although they are working in parallel, do not create just one location and increase the capacity, the number of units to 2. Create 2 different locations for late 1 and late 2. And this is just for the sake of our problem and to be able to get similar numbers. So we have 2 entities, obviously, as you can see here. We have 2 entities. One is blank, the other one is cog, but we have 1 arrival because blank is the only entity that is coming from outside. So we have 1 arrival related to blank. So we have 2 entity, 1 blank, 1 cog. And for our arrival, we have 1 for the blank, so which is simple. It goes to the receiving area 1 at a time from the start of the simulation. Occurrence is infinity. They come to the system for as long as we run the simulation, and their frequency is 20 minutes exponentially distributed. Okay, and that's the exact information I provided here. Okay. So then let's see how we are going to model the processes and take care of the resources. So before we go to the process, if we were going to just do the processes, that's easy. Obviously, we go from receiving to either late 1 or late 2, and then from these to degreasing to inspect and exit the system. So that part, the processes, is not hard. So that part is easy. What we want to know is that how can we create resources, dynamic resources in this simulation model. So before I get into processing, let me just go and create the dynamic resources. So for dynamic resources, so that they work, first I have to create a network in which I specify the path that the resources have to take to be able to move entities between these locations. Okay, so first I have to create a path network. So if you're using 2016 version, to be able to get to the path networks option, you have to go to build menu, and then you find path networks. And if you're using the 2018, path networks is available right in the screen. So we click on the path networks, and here we basically create a network. So automatically a network is created for you. You can change obviously the name of it if you want. I'm going to just leave it as net1. So here we are going to specify the network and distances between these machines. That's the one that the resource has to take as the resource is moving these entities around. So to be able to create the network, I'm going to so let's say I want to specify the distance between receiving to late 1. And as you can see here, I said between receiving to late 1, 500 feet, late 1 to late 2, late 2 to degreasing to inspect, and inspect to receiving. So basically there is a distance between all these 5 machines. So I have to specify that as the network of paths that I have, because the resource is going to use this path to move the entities around. So here, to be able to specify the paths, I'm going to click on receiving and then double click on in front of late. So it creates a node in front of receiving. It's going to call it N1, and it's going to create a node in front of the late, and it's going to call it N2. Okay, and there is distance here. So as we saw here, the distance between receiving and late 1 is 500 feet. Okay, so I'm going to put the number 500 here. Okay. So now I want to create the second part of this network. So the second part is the distance that I want to specify between late 1 and late 2. So I'm going to click on this node and the node N2, and then double click in front of late 2. So that then the next part of this path is created, going from N2 to N3. Just remember, when I created the second part of this path from late 1 to late 2, I didn't start from a new node to a new node. So the first path went from N1 to N2. The second path starts from N2, goes to a new node. Okay, so make sure your second path starts from where we finished this first path, so that these paths are related to each other, so that the resource can go from one path to the next one and so forth. Okay, and this one is 200 feet, so I'm going to specify the distance, and I want to specify the path from late 2 to decreasing. Again, I'm going to click on this node and then double click in front of decreasing. So that's, as you can see, goes from N3 to N4. So N1 to N2, N2 to N3, and then N3 to N4. And that's another 200. And then I'm going to go from this one to this node, which is sorry. Okay, to this new one. So this new one goes from the new one goes from N4 to N5. Okay, and so again, I will start from N4, which is where I ended in previous part of the path, and this one is 200 as well. And the last one is that I'm going to finish this path or this network by going from inspection to receiving. Okay, and that's going from N5 back to N1. N1 is where I started, remember here, and I finished going from N5 back to N1, and that's another 500. Okay, so to create a path, just make sure, let's say if I click here and click, and then I can double click, a path is created here. So this node, this little thing here, is not part of the nodes. It's just if you want to create a path that has ups and downs and you want to show it, you can just click, 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 similar to a queue. And then when you want to end the path, like create the final node, you can double click and the final node is created. So that's just to show you, you click, and then if you click to start, and then if you click in the middle, so you can just go ups and downs, but these are all part of the same path. And when you double click, the end node is created and you are done. So this is a new, obviously, as you can see, path. The start is N6, nothing that I have had in the past, and the end is N7, again nothing that I have had in the past. So I just created this as an example, so you guys see how we create a path. So I'm going to delete this because that's not part of our problem. Okay, so I created this network for now, and I specified the distance of these parts of the network. The next thing I need to do is to tell the simulation that each node represents which machine, because right now all I have done, I have created these nodes, right? But simulation doesn't know this node represents receiving, these nodes represent late 1, this node represents late 2. So I have to tell the simulation that what these nodes represent. So when a resource brings a part from node N1 to N2, that means the resource is takes the part from receiving and takes it to late 1. So I have to tell the simulation what these nodes represent. To be able to do that, I click on interfaces. Okay, so the same place that we are, I click on interfaces. So this window opens, and then to be able to relate the nodes to these locations, I click on each node, and then I double click on the location. So that, as you can see here, shows N1 represents receive, and then click on the node, double click on the location. N2 represents late 1. Click on the node, double click on the location. N3 represents late 2, and N4 represents degrees, and N5 represent inspect. Okay, so that's what we call by creating interfaces, meaning that we tell the simulation that what these nodes represent, because just creating a node in front of a machine doesn't mean that the simulation understands that nodes represents that machine. We have to create the interfaces so that we tell the simulation what do these nodes represent. Okay, so if you want to go back to where we showed our network and distances, we can always click on the path, and that always takes us to this area if we want to change any of the distances or so forth. And as you can see here, for distance or speed, if I double click here, for example, in the distance and the speed, I have the options that am I going to use the distance and the speed? Because similar to conveyors, I can specify the length, and then I also specify the speed of the conveyor, and then the time that it takes to go from one side of the conveyor to another is calculated automatically in the simulation. I can do the same here. I can either give the distance of going from each node to another and speed of the resource, so that simulation calculates how long does it take for a resource to go from one node to another, or I can just give the time that it takes to go from one node to another. So you can specify that these values, for example, if I put time, you see this part changes to time. If I change it to time, that means this 500 is time in minutes of going from one node to another. Okay, but I don't want this to be time. In my simulation, these values are distances from one location to another. So I go back to this, click, and I pick speed and distance. So then these values are not time, they are distance. So what I tell to the simulation is that what is the distance between these locations, but what I have to tell later is that what is the speed of the resource, so that the simulation can calculate automatically how long would it take for a resource to pick an entity from this point and go drop it off at late one, for example. Okay, so make sure to save. Okay, and okay, now the next thing we need to do is to specify a resource here that is going to use this path to be able to move entities around. So I'm going to resource, I'm going to create a resource here. Okay, I'm going to call it, for example, operator. Okay, so I'm going to create a resource. Pick any icon that you want. We are going to create a resource. We are going to have one unit of this resource, only one resource in the system. And the way to tell the simulation that this resource is going to use this path to move around and to move parts around is that we are going to go to a spec. Okay, so when you create a record, after we are done and everything, we are going to go to a spec. And here, when we click on the spec, this window opens. So here, I'm going to tell the simulation that this resource, which path network we are going to use. So we are going to use this path network that we just created, and its name is N1. Okay, and when I choose that, the simulation also highlights the path network. Okay, then here it says, okay, where is home to this resource? So meaning that where are they as their home, like where is their original location. So you can specify any of these nodes n1 to n5 as your home. So I keep n1, which is this node in front of the receiving, as home for this resource. Off shift, meaning that when we are not in the working time, if we are, for example, in a off shift, in a non-working time, where does this resource is going to go and wait? So I'm going to again pick N1 and then break. So if we have some break time, where does this resource go and wait or rest? And again, I'm going to choose N1. So you can put any node here, that doesn't matter. So here I put N1 as the place where this resource is going to go in off shift, in break time, and also as a home at the start of the simulation. And then here, as you can see, we can specify the speed of this resource when it's empty or when it's full, meaning that when the resource is not carrying anything and when the resource is carrying something. Sometimes, for example, I may tell you, oh, we use a forklift for moving entities around or moving parts around. In that scenario, forklift is my resource. And I may tell you that this forklift has a different speed when it's moving part and has a different, and it uses another speed when it's not moving part. In that scenario, you have to put different speed when it's empty or it's full. If I don't tell you the different speed for when they're empty or when they're carrying something, then just use the same speed for both empty and full. So here in this example, our resource has the speed of 100 feet per minute, both when they are empty and they are full. So both when they are carrying something, when they are full, or when they are not carrying something. In both scenarios, the speed is 100 feet per minute. And as I told you, if we have some pickup time for the resource or some drop-off time for the resource, we can also specify that here. So here we assume 120 seconds for pickup and drop-off or deposit time. Okay. So this is something given. If pickup time or drop-off time has not been given to you, then there is no such a time, so don't put anything for pickup time or the drop or deposit time. And as you can see, the units here are seconds. For everything else, it's feet per minute, but the units here is that how much time does it take to pick up an entity, how much does it take to drop off an entity, and these are 120 seconds. Okay. So with that, we specify our path network, which is the path that our resource is going to take, or we specified our resource, and we told our resource which network, which path network it should use for moving the parts around, and what is the speed of the resource in different, and what is the speed of pickup and drop off. Okay. So now we are going to go to processing and specify the path that our entity is going to take, or the path that, or basically different operations one after another, and specify how we can tell the simulation at this part that our resource is in charge of moving parts around. Okay, to specify the processes, so our entity goes from our entity, which is blank, goes from receive to late 1 or late 2, and let's assume the entity is going to take turn between late 1 and late 2, so it's going to be by turn. Okay, so blank goes from receiving to late 1 or late 2, and just make sure here they are not a new block. Okay, so these both lines are part of one block, so it's going to late 1 or late 2, they are going to take turn. And then here we basically specify in the move logic, we say move with operator then free. Okay, so that's all basically we have to say. Move with operator. Operator is the name of our resource, so move with the resource then free. I don't need to specify the time, because previously, if you remember, we would say move with resource for this amount of time then free. So if you remember, we previously either had simple move time, we would say move for this amount of time, for example. Okay, then we say move for move with the name of the resource for whatever amount of time, then free. Okay, and now this is the scenario where we use a static resource. If you remember, we had a problem with the static resource. We say move with the name of the static resource for this amount of time, then free. Okay, we have to definitely put then free so that the resource is free to move other parts. But with dynamic resource, all we have to do is move with the name of the resource, whatever it is. I don't need to specify the time anymore, because I have a network that has a distance and has a speed, and then we say then free. Okay, So with the dynamic resource, I don't need to specify the time because I have a network that has a distance and has a speed, and that distance and speed specify the time that it takes to go from one point to another. So I don't need to specify the time anymore. Okay, and just make sure to run it. Just make sure the code is correct. And I'm going to basically copy this and paste it in all the move logics. Okay. And then the blank goes, then blank is the entity that is going to come out of yeah, sorry. So the blank is the entity that is going to late one. So blank is already at late one, and the entity that is going to come out is cog. Cog. That is going to go to degreasing. And similarly, blank is the entity that is already at late 2. If the blank ends up at late 2, cog is going to come out and is going to go to degreasing. Just make sure for the for from late 1 to degreasing, also for the move logic, we are going to do the same thing. Move with operator, then free. And then for going from late 2 to degreasing, we are going to do the same thing to move with operator, then free. Okay, and for late 1, the wait time is, oops, uniform. Let me take a look. Uniform 15.5. And same here for this other late machine. Wait time is uniform 15.5. Okay. And then from degreasing, the cog goes to, from degreasing, goes to inspection. And here also for this movement, also we are going to use the operator to do this movement. And in degreasing, wait time is uniform 5.1, and then cog from finally inspection is going to go to exit. And here the wait time is normal 8 and 4. Okay. And obviously for the last one that goes from inspection to exit, we don't put any move logic. But for all previous line, there is a move with the operator. Okay, for all of the previous line, there is a move with operator. And make sure to save this. And then we are going to run this for 2000 hours. So as you can see, when we run the animation, we can see the resource is moving around on the path network we have created to move the entities around. So let's see the results. Okay, so about 4,000 cogs have left the system, and we also see the average time in the system, which is quite long. And this is mainly because there is only one resource in the system to move parts around, so that resource becomes a bottleneck. So let's go to the resources, and instead of just one resource, we are going to say, okay, we have 3 people, 3 resources that are going to help us to move parts around, and let's run the simulation one more time. So as you can see, number of parts that left the system increased, and also number of time in the system decreased significantly. So what I want to do next, okay, let's assume we want to calculate work in process. So let's create a work in process variable, and we want to just increase that in the simulation when the entity enters the system, and we want to decrease this variable when an entity is done and is leaving the system in the last line. Decrease work in process, okay? And then and then when we run the simulation, we can obviously see the value of work in process. Let me run it one more time. Okay, so I can go to variable summary, and here we see on average about 12 parts are in the system, so our work in process is 12 parts. So don't report anything else. The most meaningful column for work in process is average value. So now let's assume that we want also to use this resource to perform the operations, because so far the resource has been used to move the parts around, go from one machine to another, and that's fine, and that's what we have done so far. But what if we want to also use the resource to not only move the parts around, but also to perform the operation? So then the question is that how we can change the command to use the resource to perform the operation as well. So to be able to do that, when we go to the operation time, and so instead of wait, we have to say use operator, use the name of the resource for this amount of time. Okay, so basically that's what we need to do. Instead of wait for this amount of time, we say use operator for this amount of time. In that scenario, we are going to use the operator to also perform the operation at late one. So the operator not only moves the parts from location 1 to location 2, but also performs the operation at this location, at the destination location. And the same here. So if I want the operator to also perform the operation at late 2, instead of wait for this amount, I just say use operator for this amount. And similarly at decreasing, if I want the operator to perform the operation at decreasing, instead of wait for this much, I would say use operator for this much. And finally, for inspect, instead of wait for this much, I would say use operator for this much. Then the operator is used in the system not only as a resource that is moving the parts around, but also as a resource that is performing the operations at these locations as well. So the resource moves the part around and also waits there and performs the location, and then goes around to move the parts and performs the location as well. Okay, so with this command, we use a resource to perform the operation at these specific locations. And make sure to save it as you move on, and make sure to simulate. Okay. Okay, so the number of parts that have left the system decreased from 6,000. Obviously, this is because the operator is now performing the movement of the part and also performing the operation of the part. So they are not available all the time to move the parts around. So the process is a little slower. And the wait time in the system we see is a lot longer than previous number. And this is mainly because now that we have to wait for this operator to perform these operations, move the parts around. So the operators basically become a bottleneck in the system. That's why it takes a longer time for these parts to finally leave the system. And so these results make sense. Okay. So basically in this model we learned how to use dynamic resources for moving parts around, and how to use dynamic resources for performing the operations at the machines. So for dynamic resources, we have to create a path network. We can specify the distance of this network, make sure to specify exactly how each node represents each one of these locations. And finally, we have to specify the resource, and we have to tell that this resource is going to use this path network with these specific speeds. And if there is pickup time, drop off time, if you don't have that information, that's fine, just leave those cells empty. And lastly, as I said, when we go to the processes, we specify that we use this resource for movement and we use this resource for operation. When we use the resource for the movement, we don't need to specify the time anymore, because we already have specified that this network has a path and this resource has a speed. So the speed, the time for the movement will automatically be calculated. Okay, so this is all about dynamic resources.